Welcome back, everybody. So today we're learning about 9.5 geometric sequences. So before it was arithmetic. That's when you add or subtract something over and over and over. For geometric, it's a little bit different. Now it's about multiplication and division over and over and over. So the do now is actually impossible to do until I teach you what you need to do. Because if you try to do it arithmetically, it's not going to work. No matter what you add, it's going to be different every single time. You'd have to subtract some weird number, and then subtract another weird number. So this one, you actually have to see what you multiply and divide. So for the top, you're dividing by 3 every single time, and that gives you the next number. And then the bottom, you're dividing by 2. And so it seems like if we instead want to say multiplying, we are multiplying by the reciprocal of what we just did, 2 over 3, every single time. All right? If you had a calculator, you can confirm that. And this is what we're going to call R. Okay? And so we're multiplying by 2 and 3. And that's called R. It's called the ratio. And then we'll figure some stuff out later. But that's all we did. We multiplied by 2/3 every single time. So a geometric sequence is a sequence that has a common ratio. Each term is multiplied by a previous term by a constant number. And so here's our explicit rule. Once we figure out that R, it's just plug and chug into the formula. And for the recursive rule, it's an equals R times an minus 1 equals a1. And now to figure out what R is every single time, here's a trick. It's just a2 minus a1. So once you know the first and second number, divide them and you have R. So now we can redo the do now. R is 2/3. So an explicit formula, which is, I think, a little easier to build, is an. Now it's 243 over 16 was my a1. That was the beginning. R is just 2/3, and then it's n minus 1 for the top. You just have to write it that way. Now for recursive, which depends on the previous term, it's an equals 2/3, which is your R, times an minus 1, and then you just got to tell me your first term. A1 equals 243 over 16. Okay, so let's see what we can do. All right, so it says find A9 for this. Well, we need to create an explicit formula. All right, so explicit, we already have the formula right above. So this is going to be an equals a1r and minus 1. Now the goal here is going to be to take the second term and the third term and divide them. But now what can I multiply by to get this term? Well, if I multiply it times negative, let me do this in a different color. If I multiply this by negative square root of 3, well, the square roots would cancel and then you have the negative 3. So I just found my R. Let's double check. This number, so negative 3, times the negative square root of 3, or the negatives cancel, and look at that, I got that one. So yes, I just figured out R. R equals the negative square root of 3. So now we're ready to plug and chug into our formula. This would be an equals, well, a1 is the square root of 3, and then in here is the negative square root of 3, and then n minus 1. Okay? For recursive, so this is explicit. For recursive, that would be an equals R, so negative square root of 3, times an minus 1, and then the first term, a1 equals the square root of 3. So if I wanted to figure out a9, so let me just box this off so they don't get in the way. If I wanted to figure out a9, well, I'm going to plug it in here because it's going to be way easier to figure that out. So it would be a9 equals the square root of 3, negative square root of 3, 9 minus 1. So then, of course, you can plug that into the calculator and you'll get your answer. Next one. Find A3 for A6 equals 132, R equals 1/2. Okay, so we can use an explicit or an implicit. I'm going to use, the recursive. So I'm going to use recursive. So a to the 6 has to equal, okay, a to the 1 times 1/2, and then this would be 6 minus 1. Well, I don't know what a to the 1 is, but they told us that a to the 6 is 1 over 32, so I could figure that out really quickly. This would be 1 over 32 equals a1, I don't know that. This is 1/2. This is 6 minus 1. Here we can do some math. This is 1 over 32 equals, oh sorry, and this is a multiplication symbol right here, my bad. It'd be a to the 1. This would be 1 over 2 to the 6, or 1 over 2 to the 6th power. Oh, sorry, that would be 2 to the 5th, because 6 minus 1 is 5. So that's also 32. So this is 1 over 32 equals a1, 1 over 32. Oh, that's awesome. You can just multiply both sides by 32. And so that tells me that a1 has to equal 1. Okay, now that I know a1, I can use this formula again. So an equals 1 times my 1/2 n minus 1. And so since I want to figure out a3, that's 1 times, oh sorry, if I'm building the formula, this would be an a1. So it's 1 times 1/2, 3 minus 1, so a3 equals 1 times 1/2 to the squared power. So a3 equals 1 times 1 over 4, so a3 equals 1/4. Okay, that was a little bit tricky, but you're using the a6 to solve for a1. Let me do that in a different color. You're using the a6 to solve for a1 because you already know everything else. So once you solve it, then you can put it in the explicit formula. I know I said recursive. I meant explicit. My bad. And so now you can use the explicit formula to figure out a through. All right, final equation for the day. Write the explicit and recursive rules for all that. Okay, well first I got to figure out R. Once you know R, you're ready to go. Okay, so for R, well, let's see, what's the difference from here to here? Try multiplying by something. So times 1, no. Times 2, no. Times 3, no. It's times 4. Yes, because if I multiply this by 4, so check it out. 3 times 4 over 32, that gives me 12 over 32. And simplified, that's 3 over 8. So there we go. So it's always times 4. Okay, so then I know that R equals 4. So hip hip hooray. And now explicit is pretty simple to write. Explicit, that gives me, let's see, it was an equals a1 times r to the n minus 1. So an has to equal 3 over 82 times 4 to the n minus 1. There's the recursive. Oh, sorry, there's explicit. And now let's get recursive. So it'd be an equals r times an minus 1, and then I need a1. So it'd be an equals r is 4 times 3 over 32. Oh, sorry, my bad. Literally, you keep the an minus 1. And then this one is a 3 over 32 equals a1. And so there we go. Now another way to figure out the r is, remember, r equals a2 over a1, which this would be 3 over 8 divided by 3 over 32. Now when you have a fraction underneath a fraction, you can flip it, bring it to the top. So this ends up being 3 over 8 times 32 over 3. Cancel, cancel. And 32 divided by 8 is 4. And look at that. We got r equals 4. So there are many ways to figure out r. Pick your favorite. All right, ladies and gentlemen. So that's it for that. Thank you so much for stopping by. Work is on the next page. I'll see you all later.